Okay, so I've not done one of these whiteboard videos for a while, so I thought I'd pick up on a topic that's came up in conversation over the last week, and that's the topic of the waste hierarchy. Now, if you're not familiar with what the waste hierarchy is, it's this thing. DEFRA created this waste hierarchy in the UK. So if you're not from the UK, apologies, but this is basically the Department for the Environment and Rural Affairs who created the idea that waste has a hierarchy. Specifically, what you do around trying to prevent final disposal of that waste. Now, every country has a similar sort of framework, if you like. And many of them have suffered from this problem since they were first proposed in the 1990s. And I say problem because which I'll come on to later on, because each of these pieces of concept thinking, if you like, have always assumed that the only thing that exists as waste in any environment is the material that something is made of. So often people will talk about this in the context of glass or plastic or rubbish or whatever else. But actually, it's much more than that, because none of these materials exist in isolation. And not only that, if you're not thinking about the waste in your organization as a whole, you're not doing zero waste anyway, but crucially, you also can't find out your total scope 1 emissions. So in terms of meeting any level of current thinking, this waste hierarchy isn't complete. It's what we call necessary but not sufficient. The other problem you have with it is that, and you'll know this if you're very familiar with the reduce, reuse, recycle mantra, is that this is out of sync. The DEFRA model is out of sync. So if you take a look at reduction can apply two main things: prevention and reduction of use. So the first two layers, great, that's in order, that's where we were expected to be. Reuse, though, under the waste hierarchy, is reduction in both reduces waste, prevents the generation of waste, and also recycles items that might actually have been thrown away. Right? So when we talk about recycling, most people think of it as a mechanical or chemical process that turns one product into another, whether that is heating glass to its melting point and reusing it, or turning plastics into granulates, or even recycling cardboard into pulp. That's true, but it's also possible to recycle something that was designed for one particular purpose but used elsewhere. In addition, it's also possible to recycle items by simply cleaning them off, if you like, and then repurposing them. So, for example, it could very well be bikes, or it could be televisions, stuff like that. So basically, the refurbishment process falls into recycling and recovery. So what this does is create a very, very wide range of areas where recycling is potentially appropriate. The final thing, of course, is the final disposal. Now, that final disposal we're very familiar with. It's landfilling, it's incinerating for energy. But crucially, the incineration for energy recovers energy from it. Hence, that's why it's called an energy from waste system. So what you have is a very, very fuzzy set of borders in DEFRA's model anyway, which then takes a complex model, which we know systems are, tries to simplify it, but simplifies it to the point of being necessarily useless. Now, there's a wider question as to its appropriateness more generally, and anybody who's followed me for a while knows I don't respect anything that has not got systems thinking behind it. Because the reality is these are all systems, nothing exists in a vacuum, plastic doesn't magically appear, glass doesn't magically appear, it's not magically incinerated or dropped in landfill. There are processes to transport this stuff, which often waste hierarchies like this completely ignore. And they were designed in the 1990s to try and look at ways of raising, if you like, products up the hierarchy. And that's often what you'll hear in the terminology. You'll be trying to take something from the disposal position, where you would normally get rid of it altogether, and then try to either recycle it or reduce the production of that waste in the first place. Which is fine, but what people often forget is that the systems that we have don't just exist in the material, but they exist in the processes, as I've said earlier, but also across time. Now, what I mean by that is that you could prevent the production of plastic waste, say, and you could also reduce it. Great. But what do you do with the existing waste that we have at the moment? There are 8 billion tons of plastics around the world, right? That's 1 billion for every human being on Earth. What do you do with this? How do you deal with that process? Because that stuff has now already been disposed of. A lot of it has been disposed of. Some of it still exists, obviously, in its original form. But you have to start thinking about recovering that material and potentially recycling it, right? That's what you've got to do with it. Because otherwise, what you've got is a situation where you are leaving this stuff in the environment just for the purposes of moving to other materials. Not only that, those other materials often have bigger footprints. It's a well-known fact now that cloth, for example, textile bags are much worse for the environment than plastic bags are for a number of different reasons. I'm not going to cover that in this video, but feel free to take a look at the Environment Agency studies and Danish studies. And, big exclamation mark, read them as if you're reading a scientific paper. Don't read them from the perspective of being a climate activist, because you'll almost get that wrong and get the message wrong, and crucially then propagate the wrong information and propagate information that actually is more harmful for the environment. The other problem with DEFRA's model is when you start to work with multiple materials, some of which are recyclable, others are not, or they recycle in different ways, this model starts to break down. The conceptual model starts to break down, because people think of waste as one homogeneous mess, when in fact, actually it's made up of multiple different materials, themselves coming from different parts of the supply chain. So if we were to take, for example, a typical hand sanitizer bottle, right, as you would buy it, that is made up of 2 different types of plastics for the housing, right? So that's 2 different supply chains, right? So one of them is for the pump. The other is for the body of the bottle, right? So that will often be PET. And that has a supply chain of its own. The pump itself is made up of 2 parts. One of them is typically HDPE or polypropylene for the top, but also the metal for the spring. Right? And these 2 also have their own supply chains. So what we have here is a compound product made up of 3 different types of material, and each of them have different footprints and different waste hierarchies. And because of that, when you start to look at them as systems, you start to get a much more diverse picture than the DEFRA model of waste will allow us to have. Because there's a number of different types of waste. If anybody familiar with systems thinking or Black Belt Six Sigma, or etc., basically will be familiar with the idea of there being 7 types of waste. I would encourage people to take a look at what are called the 7 Muda, or the 7+1 waste in particular. Because what that will do is give you an idea of the types of waste that exist in the system, and that can include things like movement, transportation, people skills, whatever else. So all of that exists at system level that waste hierarchy, according to DEFRA, doesn't believe exists. Right, despite the fact that this is a ubiquitous thing. But what this basically means is that in the scope, greenhouse gas protocol scopes, DEFRA's waste hierarchy assumes that scope 3 doesn't exist, basically. Indeed, if you apply DEFRA's waste hierarchy to your own operations only, you haven't even quantified scope 1. Now, because you don't know what your total emissions are for the rest of the system. You just know about the waste hierarchy, which itself is a necessary but not sufficient measure. So if some people might say, you can argue the case that you could put forward maybe a repertoire of tools for DEFRA's model, but actually that still misses the other parts of the problem which exist inherently in these arena, right? These compound connective spaces. Because every time you've got this, your waste hierarchy now is composed of 2 things, at least, not just 1. So that means the DEFRA model completely falls over. But people still use it in public procurement. People still use it in much of their thinking. So with that in mind, when you think about things as systems, you have to look at the life cycle impacts. And I don't just mean carbon here. most people will be familiar that, well, anybody who's followed Automedia for quite a while, you'll realize that we cover 17 SDGs as our life cycle impact. That's what it means to us. That's way beyond, I get it, it's way beyond what other people are doing at the moment. But we take the view that you're not doing any, sustainable development or sustainability at all if you're not doing all of them. And that's why, we are very heavy and come down quite hard, sometimes, dare I say, on organizations who are only thinking in silos like this, because silos are not the answer to this, and you can't champion system change if you're then going to think in silos, right? So as a result of that, the two key things for us are, how do we look at improving this? And we're not perfect everywhere, but the key point from our perspective is this is how we measure it. Because if you're focusing just on the scopes, you're missing biodiversity loss, you're missing a lot of other stuff which other people have quite competently commented about. So with that in mind, when you're thinking of these aspects of systems, it's often better to view it as a system, but also be aware that there is stuff upstream of you. So that's the upstream space. Right? But because of the way waste is handled, especially when you have multiple material waste, there's a downstream impact at the recycling facilities, for example. And because those create, I'll call it further pathways that take you down one of these routes, whether that is final disposal, whether it is export for recycling, whether it is incineration, or whether it is landfill. And also, of course, recycling. So the issue here is each of these then creates further waste hierarchies. For example, long distance travel to a materials reclamation facility leaves you expending a huge amount of pollutants, and which are waste, and carbon dioxide from the trucks that take them from the bins that you put them in here to the MRF. So with that result, you're looking at, they typically only have around 8 miles per gallon to travel with. So what this means is that there's a huge amount of emissions off the back of a diesel truck just to take it to the MRF. And what's worse is many of those processes here also have big carbon footprints, especially exporting it thousands of miles. So these all create other types of waste. So what you don't want is a situation where you are optimizing for this process here, right? But actually, the net consequence of doing that increases the distance you are traveling because of this, or increases the amount of export that you're doing, because you can recover it somewhere else compared to being able to only dispose of it here. Or you could probably recycle some of it here, but in order to prevent the waste from existing, you then ship it abroad, which is an even worse type of greenwash. So the net result of that is that this hierarchy, unfortunately, hasn't been fit for purpose for the best part of 7 years or so, as a minimum. So this is one of the reasons why we never used it at the UN, because the fact is that this is an incomplete picture that itself has the potential to cause harm. So we made very, very deliberate choices there. And this is not unique to the UN either. The EU and other EU countries have made the decision that actually circularity means ditching the idea of waste hierarchies as material-based concepts, because they're not. They're way beyond that. So anytime you are thinking about these things in hierarchies, you are not thinking about them in circularity. In circularity or circular economic ways. So that's one of the reasons why, I don't view the DEFRA hierarchy as particularly credible. So that's this bit. If we now move on to looking at one of the reasons why it's not credible, i.e. in practice, this will give us a better idea. So let's shift to another part of the screen. So if we were to take just the operation of a particular type of waste. Let's take glass. Let's take one of these. Okay. So this is glass, just the material. And this is glass, total system. Now, the reason why I put these two together will become clear in a bit, but when you focus just on the material, then the most preferred option, obviously, is to prevent the creation of, or the use of brand new glass, ideally. There's the recycling of the glass, recovery of it, which again, questionable order, and the final disposal of it. And that's fair. Glass is a very highly recyclable material, not just from the perspective of the technical recycling exercise, but also the prevalence of glass recycling centres in the UK, or the uses for glass in the UK. So you don't really have to travel very far to have a glass recycling, because it's literally located outside your back door. You can literally just put them in a bin and it will automatically be taken away. Now, in addition to that, the places that use glass are, again, ubiquitous. There are many places in the UK that use glass. So the distance you're ever taking it is actually relatively small. But we'll come on to that later on. The key thing for this particular half is just the material. So in terms of the prevention of the use of glass, the only way you're going to be able to do that is if you use a different material. But of course, what other materials are there? There are plastics. There is sometimes paper, such as the paper cartons that you put milk in. And those, they have their own footprints, if you like. So the very act of doing this offsets the waste hierarchy of glass into the waste hierarchy of plastics. And the waste hierarchy of materials, from the perspective of materials only, the way it works is it's focusing specifically on the material itself, not the system-wide offset or shift from the conventional waste hierarchy into another waste hierarchy. So that is an important thing we'll touch upon when we get to the system level. As a result, the total system will offset into the paper and into the plastic processes. Reducing the use of glass, or reducing the waste that's produced as a result. And that obviously can happen through one of 2 or 3 main ways. And they tie together reduction and recycling. There are things like simply reusing it. This has energy required for cleaning, which again we're not focusing on the material only side. There is also recycling that glass into other types of glass. Now, most people will be aware that the different colors of glass, or if you're in the sustainability space, you should be aware that the different colors of glass, whether it's green, brown, or clear, are actually the products of the recycling process. Reusing and recycling glass has 2 different sort of system impacts. One of them, if we take this bit, reuse has a cleaning impact. As soon as you clean it, you have the question of what to do with detergents, and also what to do with the water, because they offset into the detergent waste hierarchy and water waste hierarchy. Right? So now we have, at system level, 2 questions around paper and plastic at the prevention level. Let's just probably make that a little bit clearer. There we go. And you've also got the questions about systemic effects on reuse, cleaning in particular with detergents and water, and of course sealing it as well if necessary. So if you have a third portion of the supply chain, which is around bottle caps, say, right? Which will exist in even virgin materials, you've still got then the cap hierarchy, which is the metal hierarchy. I'll make that clearer here, metal. There we go. So that's typically how it would work. Now, in the case of recycling glass, though, that's a different proposition. And the reason why I say that is because recycling glass cannot occur at anything under 1800 degrees centigrade. And that requires a huge amount of energy to get to that high a temperature. It requires a kiln, the 3-phase power supply. You can't do it on basically at home, if you like, unless you're using propane gas systems. So you're burning a lot of fossil fuels to get to that temperature. In industrial complexes, you are able to use arc furnaces, which can be run on renewable energy, no reason why not. But in any event, the energy consumption is high. Now, at system level again, you have the question of energy. Here we have the energy footprint, which again offsets into its own waste hierarchy. And the reason why that becomes an issue is because depending on how well the systems are insulated against dissipating heat into the wider environment, the energy itself is intensive and can cause a lot of waste. So if you look at typical kilns, they're sealed extremely well. It's a well understood process in glass, but it will take a huge amount of energy to reach 1800 degrees C. Now, recovery of material under the DEFRA rules meant that material which is disposed of, which might have been broken or otherwise mixed in with other stuff, the material is aiming to be recovered from that mix with a limited amount of contamination to then be often recycled and reused elsewhere. So there's already a relationship between recovery and recycling. So the first generation, if you like, something may be recovered, but then it will be used in a recycling process in the second generation waste streams. That creates two positions for exactly the same bottle, say, in the waste hierarchy. Different from a systems view, because of course these two processes have, well, certainly in glass, have two different ways of reclaiming that material. And it's not really in the consumer space, but more in civic spaces, etc. And that does mean that you've got to think very differently of the waste stream will be when collected by a road sweeper versus, say, a bin collection at a residential location, such as a house, etc. For example, the road sweepers these days are often powered on electricity, while very few bin collection lorries are actually powered on electricity. So you can see that there are two different ways to capture material, and both of them have different footprints, which at a system level is also a question of energy. Right? So as you can see, it's not enough just to simply estimate it, if you like, as one single file disposal, because there are multiple routes out there. And not just that, the energy, even the waste to energy processes aren't necessarily as efficient as you might assume they are, but they are obviously better than fossil fuels, because in essence you're burning fossil fuels indirectly, because plastic is made out of fossil materials. So realistically, you've got two ways to view the waste hierarchy, depending on whether you view it as a material process or a system process. But where you view it as a system process, you're not just looking at one single waste hierarchy, you are looking at multiple ones. You've got one for paper, one for plastic, we have the cleaning detergents, the water, what to do with the metals, what to do with energy, and of course the landfill process. It sounds daft to have landfill, which is a waste system, inside the waste hierarchy, but the problem with it is that in reality it's a system of systems, which is typical within any climate policy position. So you're looking at having what are effectively as a minimum, 7 different waste hierarchies to view the system level change. So it's not good enough to look at it as one single effect here, and that's just the same material in each case. Never mind what it does to multiple material positions. So when you're comparing glass with other materials, you then have the question, as we touched upon before, of comparing waste hierarchies. And those waste hierarchies aren't often the same. They're often very rarely the same, in fact. So if I was to take a snapshot of this and repeat this process with plastics, we should see a fundamentally different profile. And before we do that, what you can start to look at, when you start to put some numbers against these things, is the energy, again, required, or the carbon emissions required as a proxy for each one of these levels. Now, if I was to turn this sideways and to draw up what is effectively a histogram with the x-axis going down this way and the y-axis going down this way, with the y-axis is going to be CO2 emissions, and the hierarchy is just a hierarchy level, which you can see here. So I'll just put in some ticks so you can see how they align. So if you start to look at this process and actually start to combine not just the energy intensity, right, for an individual item, but actually all items that are actually prevented or recycled, etc., what you're hoping to see is a negative position. Now, there's only a couple of these positions which are actually negative. Obviously, prevention of creating it is one of them. So I'll have to try and remove what I accidentally do there. That has a negative position. Great. As long as the plastics and paper models, which we'll come to in the system side, don't then find themselves being the subject of that offset and increasing emissions appropriately. Reduction itself also results in negative emissions, as long as, again, the plastics and paper position aren't compromised or compromising. Recycling, though, on the other hand, as we've seen from many, many studies, results in a huge carbon footprint, mainly, again, because of the energy required to make that happen. Recovery, same thing, because that basically goes into exactly the same process, but it also has the energy requirements of recovery at the end of the day. So at a system level, it has them together, but there'll also be the addition of, try and draw a straight line, the collection from non-singular sources. Right? And of course, disposal has a certain amount of energy associated with it as well. So you'll get a profile that looks something like this. I mean, the exact numbers are available. Obviously, happy to do that individual process at some point. But that's only for the material. Only for the material. And basically the collected material. When you start to look at it as a system, these fundamentally change because you are including now all the hierarchies that we talked about before. You have to do this exercise for every single one of them and then sum the total by the offset percentages. So, for example, if we have a coefficient here of alpha 1 and alpha 2, and you went through this process until you eventually came out with an alpha, 7 in this particular case. What you have is a utility, which is the total carbon footprint in this case, say carbon footprint or energy from whatever we want to try and measure within the waste system. That will become the first factor, which in this case is the paper to plastic, the glass to plastic and glass to paper positions, which should be alpha 2, F2, right? And you'll go all the way to, in this case, alpha 7, F7 for the method of disposal. And that gives you the distribution of your energy. And it's much the same here. It's exactly the same process I've used here can actually apply in this particular initial case, because here you've just got the 5 layers, if you like, but it only gives you the total utility, if you like, of that particular glass. So you could say utility of glass material only is equal to alpha 1 times by factor 1, which is the prevention, plus alpha 2 factor 2, which is reduction, plus plus alpha 5 factor 5, which is obviously disposal. But obviously there are two fundamentally different things here. The first one, like I said, is that this only measures material in glass. Right, that's why we had to subscribe to this G. And the second is that because it offsets into the other waste hierarchy, it's incomplete. It's not got all the information required to make a judgment on the appropriateness, if you like, of the glass hierarchy in this, or glass waste hierarchy in this case. And you can combine these together by reformatting this systems-based one, obviously, through some delineation, if you like, of these factors, which may combine into creating these alphas. If I was to then sort of simplify this a little bit, I'd say mathematicians out there to be a bit more correct. What this gives us is the ability to ask the question: how many of these coefficients, if you like, combine into making these coefficients? So, if we now take it to the specific case, not the general case, which is what we've been looking at so far, we can say that the total waste, we'll put that here, is equal to some factor of the glass waste plus some factor of the plastic waste. Let's go L for plastic. Let's go 2 sets here. Plus paper plus energy or whatever it is. So in essence, you're then combining all the individual utilities into one. But that's not enough, because not all of them will necessarily pass through all of those stages. So you'll have some beta function, coefficient rather, that will then get you down to what will be ultimately the combination of alpha elements to make those beta. So beta itself will be defined, let's call it n is equal to some combination of alpha 1, alpha 2, plus etc. So with that in mind, you're now able to start to rationalize these two systems and actually look at it as a proper system. But you have to be mindful that not everything will necessarily pass to all places, because not all glass will necessarily be replaced by plastic, or that not all glass will be replaced by paper or card. So when you're rebuilding that distribution, if you like, on this side as a systems distribution, you're now looking at a much wider range of factors which can result in waste, and some of that waste is a byproduct or secondary to the actual waste that you're primarily processing, such as energy, emissions, pollutants, etc. So that's one example. So that's the end of part 1. That kind of shows the problems within the waste hierarchy using the waste hierarchy when you only view it from the materials perspective versus total system. I've shown here how you can combine the two potential systems, but you must also find out what these coefficients are. What I'm going to do in part 2 is compare different materials to show what the waste hierarchy look like in each case. Stay tuned for that one. Any questions on this one, of course, drop it in the comments as always. I'll try and put more of the detail around some of the sources for some of the data that I'm talking about in the captions associated with this video, and hopefully we should be enough information. But if I miss anything, of course, let me know.